right? So last class we started with this log-based protocol. So you have two types of logs. In the case of log-based protocol, one is going to be a shared mode log, and other is going to be exclusive mode log, right? So if a transaction has acquired a shared mode lock on a particular data item Q, it can perform only read operation on that particular data item capital Q. Whereas if a transaction has acquired an exclusive mode lock on a particular data item capital Q, it can perform both read operation on a particular data item and write operation on a particular data item, right? So we saw this compatibility matrix, right? So when both the transactions ta and tj, they want to perform shared mode lock on the particular data item q, it is permitted. Else that does not exist any compatibility between the two transactions if one is going to be shared and other is going to be exclusive, or uh, the what of the transactions are going to be exclusive mode logs, right? So last class we started with this simple example. So the first transaction is to debit $50 from account B, and it has to credit it into account A. And the second transaction was to read the values of account A and account B, and to display the sum of accounts A and B. Since we are going to use a log-based protocol, what we have done is that whenever you are going to perform both read operation and write operation on a particular data item, we were using exclusive mode lock, right? So we have an exclusive mode lock for the data item B, similarly data item A, whereas whenever you are going to perform only read operation on a particular data item, you are going to perform a shared mode lock on the particular data item. So you know that, right? So the initial values of the accounts A and B are going to be $100 and $200 respectively. And you know that when the transactions are executed serially, T1 followed by T2, or T2 followed by T1, the database will be a consistent state, right? So initial value of B is going to be 200, 200 minus 50, it's going to be 150. And initial value of A is going to be 100, 100 plus 50, it's going to be 150, right? So it's going to be 150 plus 150. The values of accounts A and B are going to be $150 and $150 respectively. So the sum of the accounts A and B is going to be $300 at the end of the transaction. So money is not created or destroyed during the process of this transaction. In the case of log-based protocol, the sum of the accounts A and B is going to be 300. So the consistency is preserved in this log-based protocol, right? So however, we'll study what happens when the transactions are executed concurrently, right? To improve the throughput, we want the transactions to be executed concurrently. So what happens when you are going to execute this transaction concurrently? Raghunath, sorry, Rahul Nant, you are the right, Rahul. Samuel, Samuel, Supriya, Supriya Prasad.
Yes, sir, present.
So you are the right.
Yes, sir.
Right. So what happens when you are going to execute this transactions concurrently, Supriya? So the initial
Okay.
value of account B is going to be $200, and the values of account A is going to be $100. So what happens when you are going to execute these two transactions concurrently?
Okay. So the value of A is 200 and value of B is 100.
No, no, value
Um,
of B is 200, value of B is going to be 200, and value of A is going to be
A
100.
is going to be 100.
Let me show you.
So,
So A value is going to be 100 and B value is going to be 200.
okay.
Right. Tell me.
Um, okay. So at first we are going to log the value of B, and
Right.
then yeah, and then the block is granted by the concurrency control manager, and then we are reading it and then subtracting and writing. So the value of B 150, that will be written, and after that it is unlocked, and then a lock is asked for a variable, which is again granted, and then the transaction T2 will read A and then unlock A. A, when it will read, it will be 100 only, and then it will again ask for lock for B, and then it will again read B and unlock B, and it is going to display A plus B. So A plus B will be 150 plus 100, which is 250. And after that, T1 requests lock and it will read, and A will be 150 minus 50, which is 100.
Uh,
So
A value is now, what's the
A
value of
is
A?
A
100,
is
right?
150, and 150 minus 50 will be 100, and then it will be unlocked. So
Uh,
at last, both values should be 100, 100.
Sorry, I think you are wrong, Supriya. And the A value is going to be 100, right? So first we start with an exclusive mode lock, since you are going to perform both read and write operation on the data item capital B. So what's the value of B? B value is going to be
So
200,
150 and 50 it will be.
right? It's not 150 and 50, 150 and 100.
Okay, well,
Yeah. Oh, sorry. 150 and 50. Yeah, correct.
Yes, sir.
So right. Right. Okay. So initial value of B is going to be 200. 200 minus 50, it's going to be $150. It is going to read the value of A and B and print it. So A value is going to be 100 and B value is going to be 150. So it's going to print the sum as 250. And now the value of A is going to be 50, right? So it's going to read the value of A. A is going to be 100. 100 minus 50, yeah, $50. Correct, Supriya. Sorry. So the thing is that, so you all know that whenever you execute things concurrently, you need to do something. You need to have some mechanism to ensure that the database is consistent. Else, in this case, the transaction T2 displays the sum of $250, which is incorrect, right? So the sum of the accounts A and B should be, when it is being read and it is being displayed, it should be $300, whereas here it displays the sum as $250, which is incorrect. So the reason of this mistake is that we find that T1 unlocked the data item too early, as a result of which T2 saw an inconsistent state. So here what we do is that here we have we propose something called a growing phase and a shrinking phase. So we are going to delay the unlocking till the end of the transaction, right? So we are going to have two transactions, T3 and T4, corresponding to T1 and T2, where the unlocking is delayed, right? So we are going to rewrite the transactions T1 and T2 as T3 and T4, where the unlocking is delayed till the end of this transaction, right? So the same instructions, you are going to acquire an exclusive mode lock on a data item capital B, read a particular data item capital B, perform a debit operation on the data item capital B, and write the updated value of the data item capital B. Again, acquire an exclusive mode lock on data item capital A, read the value of capital A, add or credit $50 into the account A, right? Or update the value of the account capital A, and there, once you use a particular variable, you use to unlock it, whereas here you are going to delay the unlocking period till the end of this transaction, right? So that's the difference between this first transaction T1 and transaction T2. In transaction T1, you are going to unlock once you complete using a variable, whereas in the case of transaction T3, we are going to delay the unlocking period till the end of the transactions, right? So similarly, you are going to acquire a shared mode lock on the data item capital A. Again, a shared mode lock on the data item capital B, display the sum of accounts A and B, and you are going to unlock the accounts A and B at the end of this transaction, right? So transaction T4 is another version of transaction T2, where the unlocking period is delayed till the end of this transaction. Now we are going to execute these transactions concurrently, right? So now we are going to execute the transactions T3 and T4 concurrently. So what happens is that, right? So both the transactions are executed concurrently. So In transaction T3, you are going to acquire an exclusive mode lock on the data item capital B or account B. You are going to perform a debit operation on that particular data item capital B, right? And you are going to update the value of the data item capital B, and over a period of time the CPU switches its CPU time to the second transaction, right? So transaction T4 acquires an shared mode lock on a data item capital A. It reads a data item capital A. Now it is going to acquire a shared mode lock on a data item capital B, right? So will this happen now? So 1 minute. Right. So you all know that when some when a particular transaction is holding an exclusive mode lock on a particular data item, it is not possible for some other transactions to acquire an shared mode lock on the particular data item. So what happens is that this both the transactions will not be able to proceed, and it results in an deadlock state, right? So transaction T3 holds an exclusive mode lock on the data item capital B, and transaction T4 it requests an shared mode lock on the same data item capital B, and both transactions cannot proceed since both the transaction like a transaction T4 will not be given a shared mode lock on the data item capital B, because uh, some other transaction is already holding an exclusive mode lock on the data item capital B. And similarly, transaction T3 wants an exclusive mode lock on an data item capital A, and transaction T4 holds an shared mode lock on a data item capital A, right? So again, transaction T3 will not also be able to proceed. So both the transactions will be waiting for the other transaction to complete, and this is known as deadlock, right? So you know this compatibility matrix, right? So when both the transactions they want to perform a shared mode lock on the particular data item, it is being granted, whereas one is holding a shared mode lock and other is requesting an exclusive mode lock on the same data item, it is not being granted, right? So again, one transaction is holding an exclusive mode lock on a particular data item, and the other transaction requires an shared mode lock on the particular data item, again it's not granted. So both the transactions they request an exclusive mode lock on a data item, again it's not granted, right? So what happens when you are going to execute the transactions concurrently is that it results in a deadlock, right? So consider the partial schedule in figure 15.7. So this is the partial schedule in figure 15.7 containing transactions T3 and T4. So T3 is holding an exclusive mode lock on data item capital B, and T4 is requesting a shared mode lock on data item capital B. So T4 is waiting for T3 to unlock B, right? So T3 is holding an exclusive mode lock on data item capital B, and T4 is requesting a shared mode lock on data item capital B. So this is the first case, and the second case is that similarly T4 is holding a shared mode lock on data item capital A, and T3 is requesting an exclusive mode lock on data item capital A. So T3 is waiting for T4 to unlock A, right? So again, there is a shared mode lock on data item A by transaction T4, and transaction T3 requests an exclusive mode lock on the same data item capital A. So what happens here is that we arrive at a state that neither of these transactions can ever proceed with its normal execution, and this situation is called as deadlock, right? So we have a situation in which both the transactions cannot proceed to its completion, and we call it as deadlock.